Hey, these are parent function notes for Monday, October the 4th, and this is a pretty quick notes template that we worked with today, talking about parent functions. The parent functions, the family of functions, a just really easy working definition for the family of functions. Basically, these graphs or functions will all have, let's see how we want to say this, the same x. So when we look at the families in just a moment, that'll make more sense. But basically, when you're dealing with a family of functions, the thing they have in common is they all have the same type of x. A parent function I like to think of as the original, or we can think of it as the purest form of the graph. It basically doesn't have a lot of numbers in it. It doesn't have parameters in it that would cause it to change. It is just simply the very, very original or first way that that function was ever created. So there's three families we're going to deal with. Let's close the ink layer, save for page. There we go. There's three families that we're going to be dealing with, specifically in Algebra 1. There's actually seven parent functions that your student will learn between now and Algebra 2 when they graduate, or even pre-cal possibly if they go that high. But basically three that we work with Algebra 1. The first name of the family is linear. The second family we're going to talk about is quadratic. And then the last one is absolute value. The parent function for linear is y equals x. Basically, linear functions have just a plain old x in them. It doesn't have any exponents or any symbols around it or anything. It's just a pure form of x. And when we go to our calculator to graph these, the students see that the parent function for x runs straight through the origin, which mine didn't really. In my picture it didn't look very good. But it does run straight through the center of the graph and come up. It's a perfect straight line slanting upwards to the right, and that's the linear parent function. Now, any graph from this that's also linear will also have the straight line characteristics, but they could be sloping steeper or flatter. They could be going different directions or have a different starting point. They may not originate from the origin, from 0, but the linear parent function, the very first one created, so to speak, the parents are just pure and are y equals x. So then the quadratic parent function changes just a little bit, gets a little fancier, the kids like to think of, and you've got y equals x squared. So if we type in y equals x squared on our y equals screen on the calculator, we discover that the quadratic parent function is just a really nice little curved parabola. It also touches the origin. That's one thing that the parent functions have in common with each other, is that they all go through the origin. They kind of like start at the very, very center. So other quadratic functions that you'll see might be wider or narrower than this one. They could even turn upside down and be a u upside down. But the pure form of the graph, y equals x squared, is characteristic. Anytime you see an x squared in a problem, then that will give you a quadratic graph. And then the most fanciest of all, the kids like to say, is y equals absolute value of x. It's the one that's very crisp and sharp. It's not just a straight line. It's not plain like linear. It's not curved and fancy like quadratic, but it scoops down, hits at the origin, and makes a perfect V and comes straight back up. So they really talked about in class today, making a joke that the linear is, like maybe the common people, and then quadratic gets a little bit fancy, but absolute value is the fanciest of them all. It's very sharp and deliberate, and it has definite values going down and up. So anytime you see a graph, an equation that has an absolute value of x, you'll know that that's the absolute value family. The parent function would be y equals absolute value of x. If you see an x squared in the equation, it would be quadratic, the parent function being y equals x squared, and then linear, of course, just has a plain x, and the parent function is y equals x. So what is helpful to know, in knowing these parent functions, it's super helpful to know that, because then you can look at other equations and be able to tell what parent function they belong to. For example, if we go to the bottom of the page, using your calculator, if you have one, you want to type in each one of these to be able to tell what family they come from. Although I was pleased, absolutely thrilled with the students that very, very quickly they discovered they really didn't have to type these in on the calculator, that they could just simply look and tell what family these came from, which parent function it belonged to, based on the type of x in the problem. So for example, the first example, 3x minus 4 would be linear because it's just got a plain x. Now the second one has an x squared and a plain x, and so we went ahead and typed that one in, and we discovered, in fact, it is quadratic. So there's a little bit of precedence that takes place sometimes. If you basically have to look for the higher power, so to speak. So since this one has an x squared, it would be quadratic. I'll abbreviate a little bit here. We have multiple x's in this problem, but they're all still just to the first power, so that would be linear. The next one, I believe, has an absolute value symbol around it, so of course that would be our absolute value parent function. Those come from. Now, notice there's numbers in this one, and there will be, the graph will look very different, but it will still have that V-shape origin, even though it doesn't go through the origin anymore, so that's how you can tell it's part of that family. A squared will be quadratic. Another squared, quadratic again. We see absolute value in this one. This guy will be linear, even though he has a function, he's still just a straight line. X squared will give us a quadratic. And then finally, the last one is absolute value again. So I was really, really impressed with the kids that, not that they were being lazy, that they didn't want to use the calculator, they just discovered that because they had watched the definitions of the parent functions, they really knew what they were looking for and could almost predict what the graphs would look like based on the family they came from. This is great growth. This is, we're kind of doing this parent function section new this year, and I was absolutely thrilled at how quickly the kids caught on to it, and I think it'll help them a lot down the road as we work with graphs and try to discover which families they come from in the future.